COCO Computer 3 Graphic Text, Lesson 18, Part 3. Quick overview. I'll be supplying some code with this portion. You'll get two object files, two bin files called letters.320 or .256. And it all depends which screen you're working with. If you're working with a 320 pixel or 256 pixel, which one you want to load in. This letters, they operate up at D00 in block 35 when you're in task 1. Okay, stuff we've all talked about in the past. We'll kind of look a little bit closer to that in a little bit. Excuse me. The normal loading of the program is done like this. Here's a basic program. We're going to see what's at FA block FFA2. That's the range from 4000 to 5FFX. We'll save that. We're going to put our block 35 in there. So block 35 now, you can address it at 4000 to 5FFF. We'll load them in whichever one of the letters when we do, either 320 or 256, with an offset of hex 8000. When that's loaded in, then we'll restore back what we peaked before we put the system back, and then you can load in your program right here. Okay, we did this before, but I'll tell it again. Okay, letters programs, they operate at D00, and we're going to an offset of 8000. So you add these two together, and it gives you 15000 hex. Okay, well, our addressing only goes up to FFF, so you can disregard the 1. So once you add them together, you end up with 5000. So when you do the load M, it adds them together, it's going to put it in 5000, which is in that mid-range of this block here, so it's going to go right into block 35. Because you can't load, excuse me, into D00 directly because disk basic is at D00, so you can't be loading over yourself, so we're going to load it in, and when it comes into use, it will be in the correct spot. And how does that do? Okay, here's our block 35 when it's in task 1. What we're doing here is we're going to put it down here at this 4 to 5000 range. Our basic program is here. You do a load M at D00 plus 8000, which is our 5000, so it loads it in right in here. And then whenever you call it in to task 1 later on, block 35 will be here. And right there is where our D00, that's where our code will execute. Stuff we did in the past, just to review that. Here's the stuff we must do for the programs. I'm going to give you, like I say, the source code for our test today, plus the object libraries. The actual letters program loaded, that's pretty big and pretty complicated. We're going to take 4 or 5 lessons worth of stuff to get through. But anyway, any calling program must have the below structures at D020. Okay, put this in your program, arg D020. You can use this here. I'm using LTR underscore letters. That's this structure down here, okay, which has a background palette register color, a foreground color, the column you want it to go on, the row you want it to go, and the character you want to put on the screen. That's the structure. We also have another structure right behind it where MSG for message. That's underscore, message, underscore, and that's this structure down here. Very similar, background color, foreground column, row, and the pointer to the message you want to put on the screen. Okay, so we're going to look a lot more at this here coming up. Like right now, if you want to put a message on the screen, what we do is you load the color you want for use as a background color for that particular message. And we'll get into where these here are equated at. I'll show you later on. Underscore black for our background color. Store that in msg.bg, okay, which would be right here, message bg. Normal structure stuff. Light gray for the foreground color. Store that in the foreground color. One in column 34, we'll store that in column. Row 2, we'll store that in there. Load up the message we want to put on the screen, whatever the name of your message is, put that in the message. So at this point in here, we've done all 5 of these. We've populated all 5 of these required things in the structure. And we'll do clear A. Okay, what A is, it's you can load 0 or clear A. It's just quicker. Okay, the passing parameters to all the feature functions we're going to look at are passed in register A. So if it's a 0 in A, we do a jump subroutine, do message, and you'll get all these addresses and where they're equated at and coming up. So that just tells this function here to print this stuff on the screen. So we'll put it on the screen, and then you go do whatever you want to do. And if you come later on, you can say put a 1 in register A, jump routine to that same routine, and it will erase the screen. We'll back up here. All the things you put into this structure here, what's up at D20, okay? Anything you put in here or you put it in the letters one, it does not change. Whatever you put in there stays in there until you change it. The letters program itself does not affect. It reads this but does not write to this. So whatever you put in there stays there until you change it. So you could print this message, go on about your business, 5 minutes later come back and say erase it, erase it as long as you've not put anything else in there. Okay, let's go on to a letter. Same thing. With a black background, a green foreground. Here's the character we want to print. Put it there. Here's a column, a row. Clear out there. Do a letter. It will put that letter, that T on the screen where you told it to. And come back. You can come back later and say, put a 1. It will erase that letter from the screen. Now we have another one down here is restore letter. And what that does is when you print this T to the screen, whatever is on the screen, right? Whatever is on the screen, it will keep that, all that information, all 32 bytes of that screen that it does to put that on there. You can come back later and restore the screen. Okay, it's restore for this letter, the very last letter you did. It will restore the screen back, which means you put it on the screen and the screen comes back normal. This one here just erases it to the background color. So it's two different functions. Okay, here's all the functions that are inside of letters.320 or 256. And the ones you can use is the ones with the asterisks over here. I could have straightened this out, but it's a lot of old code that uses this. So do message, we just talked about. Do letter, we just talked about. Here's some internal stuff, okay. This get letter, okay, it's internally sounded, but maybe in a previous, I think in lesson 1, we talked about how all the letters are in the ROM up at F something 09, and how we broke them out. Remember, it was 8 bytes long and all the bits in there covered. Okay, that's the function internally in my program. It will go to the ROM, it will get that and unpack all that stuff and put it in a holding area that we work on. And we got these are internal stuff. Here's that restore function. These are not used anymore. I could eliminate them, but I've got old code that still uses these functions. I'm just not going to go back and change the programs. Here's the mask that we use for your background, foreground color. That's internal. And we got some other functions: copy letter, paste letter, spacing, which we talked about how you can space it different when you print a message out. You can rotate the letters, 0, 90, 180, 270. That's there at a function, and a font 1 or 2. We're going to look at each one of them right now. So copy paste. Right. When you like in our example, we printed that letter, I think it was T or A, whatever it was, to the screen. We printed to the screen, we give it a row or a column or a color, whatever we want to do, and we put that letter on the screen. All right. Internally in my program, and this I just did a copy and paste into here. Internally in my program, here's where all the information for that letter that went on the screen is. All right. Restore address, it's the calculated address of where on the screen it's going, row, column, plus the offset of where it's sitting in memory. So it's the actual physical address of where that A is on the screen. And the width and the height is kind of redundant because they're always 4 bytes by 8 bytes, or 4 bytes, 2 pixels per byte, so 8 pixels. So it's 4 by 8, it's always the same. And the actual data, the 32 characters like we talked about in a previous lesson, is there. So these 36 bytes are what be able to refresh that screen. So you do a do letter, you load up your save area, okay, and in your program you put a save area of 36 bytes, and you do a jump subroutine to copy letter, and it will copy from internally out of my program into your save area for later. You can come back whenever you want. Okay, you can do whatever you want, and then you come back at some other point in time, load up that save address again, put your pointer to your 36 bytes, and jump subroutine paste it. Will take it out of your area, put the 36 bytes back into this area, and you would do a jump sub restore letter. It will refresh the screen as the way it was. Seemed like a lot of work, but again, just say if you had 4 things. They don't have to be letters. They could be some of them special characters, or they could be letters. It all depends what you wanted. So say you had 4 of them, okay, and they were doing different things based on input from somewhere. It was a game. I don't care what it is. There's something that would cause you to change one of them letters. So if you had like save letter 1, 2, 3, and 4, okay, you could do a save for all this for your letter 1, your 2, and 4, and something happened and letter 3 changes, you could point to letter 3 save area, paste it and restore it to the screen, and then put it back on the screen wherever you want. Later on you could do area 1, area 2, area 3, so that's just multiply. Now this only works for a letter. It doesn't work for a message. Messages are kind of tricky because they could be big. They could be 40 characters across the screen, or even longer than that. If you do a spacing of 6, you get more. You get 50 some characters across here. That's over 1,000 bytes. Plus, if you do some spacing, you got spaces in between. It gets very complicated and very big. So it doesn't work with a message, only a letter. Spacing, rotate, and font. Okay, there's some more of the other options. Okay. The different widths you can do on there. Normal is 8. You can put in there whatever you want. You can put 6, 7, 8, 9, 10, 12. Okay, it only works on even numbers, so you can put 7 in there. But internally, when you do a shift to divide it by 2, you're going to get the same answer. So, and you can put 14 or anything you want in there. That, and jump subroutine spacing, and anytime you do a message, it will use that as their spacing. Again, that becomes the default until you change it again. It doesn't automatically go back to normal 8. Let's say you run your program, you change it to 6, and you reload another program without reloading the letters program. The default is now 6 until you change it. So it just stays internally at that until you change it. Same way with rotate. 0, 1, 2, or 3, 0, 90, 180, or 270. Once you change it, it stays there until you change it to whatever, back to 0 or whatever you want. Font is either 1 or 2. We looked at all the different things in them control characters from 0 through 1F. Remember with font 1 or font 2, that's how you select the different fonts. Okay, jump to them routines. Again, all 3 of these stay as your default until you change them. Nothing else will change them. Couple notes. I already told you that there's 2 versions. It only works with 16 colors. It doesn't work with 4 color, 2 color, or just for 16 colors like that. No error checking. What does that mean? Well, there's a lot of code in there, and from my past many years of programming experiences, error checking takes a lot of time, a lot of cycles, and a lot of code and space. So, and most of this stuff that we're doing here is putting letters on the screen. Well, all the errors will fall out when you're testing your program. Example would be, let's say you want to put it in column 50 and you have a typo, and you type in there column 500 instead of 50. You store that, you come to go off to this program up here, when you're testing is going to show that up. Okay, I mean it's just not going to work. Okay, so you'll find that out there. So your program will do all the checking prior to coming, because to check every possible combination coming in of colors, rows, columns, addresses. It'll fall out in your program. The only thing that could be different is if, and I don't know why you would want to, but if it's coming in from an input, the end user is typing something on the keyboard and you're passing it directly into this, which I don't know how you could or why you would, okay, that could have a problem. It will rely on you to do the checking. Okay, well, here's a program. I'm going to supply this program, the source code letter test 7, and I'll supply the common.include, the macros, and a new one, letters.include, which has all the equates, which we're going to go over here shortly, and another one called colors.all.inc, and that takes care of all the addresses of all the various registers and colors. And I'm going to take a pause this. I'll be right back. Okay, I'm back. I just wanted to set the screen up a little bit different. I'm trying to do this on a split screen. It's going to be an easier. I don't know how easy this will show up, but I already got the program loaded, so I'm going to execute it. Hopefully it's big enough where you can see what it does. Okay, this is a program supplying all this code, and it's a long program, and it's not very nice. It starts here and ends there. There's no, you see it's long, but it has an example of every possible thing I've discussed in the past 3 weeks, or 3 lessons, let's put it that way. Okay, we got a heading there. We got some different, using the different spacings, okay, colors. We print out a line up there, and we do it upside down, and we press any key to erase that. We do that, and we'll get our erase in there. Hit the space bar, and it's going to put out a bunch of other examples, and we got a box moving around there, and it's going to stop in the middle and put a red dot in there and give us some things, which we'll talk about when we get to the code. Okay, what it's going to do with that. We'll hit the space bar, and it will put an A on the screen where the box was. That will restore our box. That there will print the letter box there. Remember, it's all done with text characters, no graphic stuff. And print 10 of them T's inside there. We'll erase them and Q to quit. Okay, now let's I want to execute it again just to start it up. Let's look at the code over here. Okay, here's our code, which looks like a lot of stuff we've done in the past. We got some notes in here. Going to include our common and our macros. It will include our letters. And remember, when you put in this no COCO or no Mac, it will not print that stuff out. The long list of all that stuff, it will not print it out. Down here, if you put in no letters up here, no letters equated 0, it won't print all this stuff. But other than that, it prints all this information out here. There's a lot of it's information on how to do everything. Or get down in here to the real stuff. Okay, here's the direct page items that are within in the program that is used at basically my program. Anyway, that's the direct page stuff. Letter width, letter height, and here's all the addresses, all the functions we talked about. That's where they're all up here at D00. And it tells you again, you got to have this at D20. Okay, so here's our structures. That's all the stuff that's in that include. And here's where actual coding begins in the program. Okay, the screen starts at 2000. It ends at 9800. It could be any one of these, but we're using H screen 2 here. Okay, so we're arguing at D20. Here's our letters. Here's our message. Okay, so now we got them. The program knows where that stuff is now, so we can move on. Here's our program. Okay, and initiate a bunch of stuff like we've done for the past year, I guess. All the same kind of stuff. Turn the interrupts off, the stack, high speed, store the palette, go to task 1, clear the screen, set our mode, and here's where we actually start doing something. Okay, load A to 1, jump subroutine font. Okay, we're going to get the font on 1, the what font we want to use in our letters. Our spacing at 6. We'll load up background color of black, foreground color light gray, column 34, row 2. The message address is test message 1, store, narrow, clear A, and jump, do message. Okay, that gives us over here on this screen color computer 3 graphics test program, black background and gray colors. Okay, then we white foreground color, column 48, row, etc., etc. Here's the next message, and clear A and print that message. That's that test line spacing equals 6. I don't know if you noticed or not, but in here we did not put the background color in there because it stays static until you change it again. So we didn't need to put that in again. So we just printed test line spaced equals 6. We changed the spacing here, 8 to spacing, and now we don't need the foreground color either because it's still sitting there at white and the background is black. So all we need is a row. Well, in fact, we don't need the column either because the column we set it up here somewhere at 50, I believe it was, or wherever it was, 48, and it stays there because we're all going to be in the same column. So all we need to, down here now, all we need to do is give it a different row and a different message and print it. Now we're going to go to spacing 10, do the same thing. We just need a row, message, and print it. 12, row, message, and print it. So therefore we got all of them lines, and now you have to put a lot of extra stuff in there. Go spacing back to the default of 8. Orange color, background still black. We don't need to put it in there. Our row, column, and here's a message, and we'll print it out, and that prints that message here, upside down text, 180 degrees. All right, we'll say rotate at 180, load up at 2, rotate, and all we're doing is changing the row. Everything else stays the same. Okay, change the row, jump subroutine, print the message, and it will print it. Now it's going to print it upside down. Okay, rotate back to 0, put in a light blue, which you see is the next message, row and a column, give us the message and print it on the screen. It does. Now, hey, this is a long drawn out program, but you're going to get an example how to do each one of these things in this program somewhere. Here we look for a key, we wait for a key to come in. Whenever the key comes in, remember what we did? We did a jump subroutine to do message, okay? Now here's an example where I didn't do the load A, or load A with 0 or clear A, because in most situations in here, you're going to do load D with 150, okay? Well, that's D. Register A is going to have a 0 in it, and B is going to have the hex value 150. So A already has a 0 in it. You don't need to put it in there, so I didn't put it in there. Just example, save an instruction cycle. We'll wait for the key to come in, put a 1 in there, and say do message. Nothing changed in there, so now it's going to erase that message. Okay, I'll hit over here and I'll hit the space bar. It erased that message. That's all it does. Going to check for a key again, clear the screen, and do some more stuff. I'll hit the space bar again. There, it's clear the screen and start printing stuff again. So I need to go through all. Okay, we did our light gray one. Okay, set our width to 12 for this next line here. Change it to white. Column, row, and message is 2x. Let's look at that message. There's a whole bunch of messages down here. That was, oops, sorry about that. I guess here's message 2x right here. Okay, it's a hex 10, 11, 12, 13, 14, all through 1F. So that's all of the control characters in font equals 1. Okay, and when it's compiled, that's all it has. There's hex 10, etc. And it has a 0 at the end of a message. So like, because you can't use 0. Get back up there where we was, if I can find that. Page 2, okay. So we print that, and this is what's printed. It printed out each one of them characters. That was hex 10, 11, 12, 13, all the way down through hex 1F. That's the characters that printed out. Change our spacing back to 8. and start column 50 and draw the first, each one of these boxes over here. I'm calling them boxes. This is the first box, box 1, box 2, box 3, box 4. This is diagonal arrows, and this is up and down arrows, and this is a special. So here's box 1. Okay, we're going to put it on row 47. Column was 50, so each one of them, and we're going to print. This here is, we won't look at the message, it's message 2H, and all that message 28 is this one here, which is a hex 10. It's got 10, 10, 10, 10. It's got 4 of them, and we'll print that message. We start at row 47. We'll add 8 to it because it's 8 pixels high. Come down and we'll print another row of them. Add 8 to that 55, which is 63. We'll print another row, and then 71 and print another row. That takes care of putting that box on the screen. Box 2 is the same thing. We just give it a new column, same rows we had before, and message 2G, which is this hex 11. So we got 4 hex 11s we print. 4 different rows. Just keep adding 8 to that. Box 3, same thing. It's got a hex 12. And then our next is our diagonal arrows, which is the same thing. And you can go down and look at what these messages look like. All it's doing is printing this arrow first, and then the other arrow, then the other arrows, and it forms that. Okay, arrows up and down is the same thing. It's taking these 4 here and printing them out. That's all it's doing. I mean, you can look at it, so that's not rocket science. Okay, the 4th box is the same thing. It's using this here, I think that's hex 17. It's using this plus sign and printing that out 4 lines. Same stuff. And you notice each one of these, all you have to do is just keep changing the row number, not the column, color, nothing, just that, and just keep printing it. There was our up and down arrows. And this is one here. This has got up and down arrows and diagonals. It's printing all these arrows in the same, basically, location. Okay, so you can look how that's done. It's remember when you put it to the screen, it ORs it on there. It doesn't replace anything on the screen. It just ORs it in what's over there. So once you put one set of arrows in there and come back and OR the other ones, you get that whole thing. All I did was just change the color, so you could tell that there was something different there. Okay, single letter moving. Okay, so we got, I'm going to hit, okay, there's that letter moving. Okay, it's just going across. Again, we don't have no vertical sync. I'm just showing you how I'm moving it. And I'm going to do it again. You can see it's non-destructive on the screen. It's doing the restore, so you can travel over the top of stuff. Okay, so that's what happens in this moving letter, and you can look at that code. All it's doing is doing a loop. We're giving it a colors, the loop count, and we give it a delta. Okay, because it starts out over here, and the delta is column is -2, and the row delta is 0. So it's going to stay on the same row and back, go across the screen to the left 2 pixels each time. And we'll do this subroutine here. That's all done in this subroutine. It comes back, and then we change the deltas so it can angle down, and then back over here. So that's all that is there. Okay, now we're done with this, and we branch always the end screen 2. We come down to end of this screen, and it's going to put this red dot on the screen. It does some cleaning up here and cleans up the stack from all that stuff we just did. We put the here's the red. We put the red dot on the screen, and we use light blue, and we put some messages on the screen that tells us what we're going to do. And that says, take the red dot, hit the space bar. It's going to erase, do a do letter with the erase function. And whenever you do a do letter, remember, it takes and saves whatever is on the screen in the save area. So as it's erasing, it saves all 32 bytes of that red. And you could be sitting over top of this, or just using this as an example. We got the red dot saved. we do that copy letter, put it off into our save area, and then we print an orange A on the screen. Okay, and then we hit the space bar again, and it will we'll load up the address of that. We'll do that paste and restore our dot back on the screen, and that's what all this code is here. And it's kind of got some documentation in there. So I'm going to come over here, and I'm going to hit the space bar. It took the red dot off there and put an orange A on the screen. It has all that information stored. When I hit the space bar again, it does the restore of the dot back on the screen. It could be anything. It's just the dot was easy to do in the middle. It could be sitting anywhere. And at that point, we hit the space bar again. It's going to go down here. It's going to print this box again with these graphic letters and print here over here to print T 10 times inside the box, but its delta is 2 pixels to the right and 2 pixels down. So it's coming on top of each other. Just those examples show you how things work. And when you hit the space bar, it's going to erase them. And you're going to look for a Q. And when Q, it's done. So that's kind of it. I've got some other things I need to show you. Here's all these different test lines. There's a lot of them in here too. But I tried to get a little bit of everything in here. Now, underline problem. Okay, let's back to this thing we did on the very first in lesson 1. Everything is pretty much the same in a color computer as what the standard ASCII is, other than these couple down here. There's some problem, okay? In a color computer, the underline character to print on a screen is 7F. Well, in the ASCII table, it's 5F. So we have a problem there, okay? We go back up. Oops, get back to our code here. When you type in on the keyboard or have it in your program, or you compile your program, if you put, I want to stretch this out a little bit if I can. Okay, if you type in an underscore character in Windows or Mac, whatever you're doing, DOS machine, it's going to be a underscore A underscore is going to be 5F415F, or just the underscore character shows it's 5F. But on a color computer, 5F is a left arrow key for whatever reason, and the underline is the 7F. Okay, it's kind of, that's the only, I mean, there's one other problem with that one there. So when we print this messages out, I should leave that alone. So we get back to that screen and look at it one more time. When we print this thing out, it okay, this do letter, okay, if you don't fix it, it's going to have an arrow, do, arrow, and each one of them underscores prints an arrow out. Okay, it's just something that's in that ROM in the color computer. So what I did to fix it, and you can, was here's this message, the one that says do letter with the erase. I just made my message, I just put in there, instead of the underscore, I put 7F to print the color computers underscore, the word do underscore letter erase, and that's how it comes out. I did it for each one of them underlines. If you ever need to use an underline in anywhere, you'll have to fix it because it's a problem. Message, check for key, set our mode, that's normal stuff. Into jobs, normal, clear screen, store. Okay, here's one thing here. Move over here. In this right here, something you haven't seen before. It says all colors. Okay, load up all colors. When we do that, I remember I stored a palette and copy the new palette in to use. Okay, going to use something called all colors. All right, and that's one of the includes that I'm going to supply you with is the colors underscore all include. It also has a no printout option if you don't. Well, no, it doesn't. It prints out all the time. I'll talk about that option there. And here it drops out this code here, all colors, which is referenced back up here. All colors, it drops this out. And here's what drops out. It drops that out. Here's what all the colors and registers have in them. Okay. Register 0, 1, 2, all the way up through 15. All right, 00 is black, 04 is brown, blue. These colors are not really used in this here. It just gives you an idea. It gives you what they are, okay? Because in most stuff in my code, and a lot of stuff in BASIC is they want the palette number as opposed to the actual color. This is the actual colors here, and here underscore underscore is the palette numbers. Okay, if we say underscore underscore yellow, okay, it's going to drop out, put a 4 into your code. Okay, you come up here, palette 0, 1, 2, 3, 4 is 36 in the register, and yellow in here is, you'll see, is a 36. Okay, but what you want to use is the palette numbers. So it's by everything you're going to be using in this stuff here is underscore underscore. Okay, and then there's some other stuff I put in here so I could, when I was doing this, so I could remember what all these colors was. Because I always had to go back and look at a Word document I had to print it on. Now, go back up here to the other thing that's, you could put no color in, like we did with no COCO up front, and say no color equates 0, and it won't drop out all this. It won't drop out. It'll drop out the print, but it just will not drop out the code. Okay, I don't know why you'd want to do it. When I did it, I had an idea, but then when in real life, I said, well, if I don't drop these palette registers out, all this other stuff is useless, because these here relate to this. You know, so if you decide you want to use some other color in here, instead of this green, you want to put magenta in there. You can't. I mean, so anyway, don't use it. All right. I think we're done. I mean, I've been winding out on this thing for a long time, and I don't think anybody's even looking at it. So I think we're kind of done with all this stuff, because it doesn't seem to have many views on any of this stuff, or very few comments ever. So I just thought this was interesting. If you want to use text on your screen and put it any place you want it and be able to erase it or move text around, do stuff, it'd be something you can use. I will have a link in the code where you can get the two DLLs, the letters 256 and letters 320. I'll put the source code out there for letter test 7, and all these includes, and you can compile it and play with it all you want, or not, okay? But I think that's kind of end up all this stuff, because like I say, it's been a long time coding this stuff, and I don't know if anybody ever watches any of it. So anyway, good luck with your coding, and I'm out of here.